Hey guys, for your 1.5 notes, I would like you to make sure that you have your calculator next to you. We will use a lot of steps on the calculator, and before we get to the actual notes, I would like you to set up your calculator to degrees. How do you set up your calculator to degrees? I want you to press your mode button. Right now, my calculator is in radian. Yours might be in degrees already. If it's in radians, scroll down till you get to radians, scroll to the right to get to degrees, and press enter. And to take it back to radian, you go on mode again, you will scroll it down all the way to radian and press enter. I will not do a lot of calculation, but feel free to pause this video and complete the calculation as you go on. I'll go ahead and start with the notes. First thing I want you to find is a cosine of 39 degrees. I explained this already in class. The button for cosine, sine, and tangent are on the calculator. So all you have to do is type in cosine of 39 degrees and press enter. Cosine 39 degrees is, for example, 0.777. You will do the same thing for the sine of 102. However, for the cotangent of 56 degrees, there's no button saying cotangent. So you have to remember, cotangent is 1 over the tangent. So you will do 1 over tangent of 56 degrees, and you should get the answer. Same thing here, 1 over, instead of tangent, this time is cosine of 245. This will be 1 over the sine of 125. I will go ahead and do the last one, and you will do all of these problems on your calculator and make sure your notes are fully completed. What is this one equal to? Find the answer and write it down. I will do this one. That will be 1 divided by the tangent of 56 degrees, and apparently is 0.675. Make sure you have an answer for D and E. I'll move on to the inverse. To find the inverse of any for any angle, for example, theta is equal to the sine inverse of x. Means that an angle whose sine is x. For example, sine of 90 degrees is equal to 1. If I want to find the angle, if I don't have this 90 degrees and I'm trying to find the angle, I will say the sine inverse of 1 is equal to 90 degrees. Let's do the same thing here for A and B. Before I go any further, remember arctangent means tangent inverse. In other words, arc cosecant is sine inverse, arc secant is secant inverse, arc cotangent is cotangent inverse, and so on. There's a button already on your calculator telling you inverse. If you look above sine, cosine, and tangent, there are inverses there. So second function sine will give you your sine inverse. Second function cosine will give you your cosine inverse. And here we're looking for the cosine of 0.619, and the value here is 51.757, and the unit is degrees. Do the same thing for B using tangent inverse. Now it gets a little bit different or a little more complicated if you're trying to find the secant inverse. To find the secant inverse, you will no longer say 1 over cosine, but because we're looking for an angle, you will say theta is equal to the cosine inverse of 1 over the ratio, meaning 3.156. For D, instead of arc cosecant, it will be the sine inverse of 1 over 1.982. And the last one, for the cotangent of theta, this can also be written as theta equal cotangent inverse of 0.684. So you will say 1 over, sorry, the tangent of 1 over, of course, the inverse tangent, 1 over 0.684. And you should get the answer. Make sure you have an answer for all these. I will do one of them with you. For the cosine inverse, I will do second cosine inverse of. You can put the fraction just as you see here, or you don't have to. But I will go ahead and put a fraction after y equal 1, and that will be 1 over 3.156. And make sure I close my parenthesis, and the answer apparently is 71.527, and that's the degree value. Let's now move on to example 3. Example 3, all we got to do is change our calculator back to radians, and once it's in radians, we will look for these answers just by typing it on the calculator. Keep in mind, secant is 3.89 is 1 over the cosine of 3.89. Here we're not looking for an angle, so we do 1 over the whole trig function. If we're looking for an angle, we do cosine inverse of 1 over 3.89. Now, for cosecant inverse, for cosecant of 2.9, I would say 1 over the sine of 2.9. This one will be 1 over the cosine of 3.89, and this one will just be the tangent of 4.2. Now, how can we predict the sine? In radian, pi is approximately 3.14. That's what you have heard before. Now, if I'm looking for 2.9, is it before the in what quadrant would this be? 2.9, obviously. Let me show you. All students take calculus. Keep that in mind. And here is 0, and here is apparently pi, or 3.14. Pi is approximately 3.14. So if this is 3.14, that's about 1.57, right? So 2.9 is located in the second quadrant. Being in the second quadrant, the cosine should be negative. Speaking of 3.89, 3.89 seems to be in the third quadrant. Secant is related to the cosine. Therefore, the cosine is also negative here. Now the tangent of 4.2. 4.2 seems to be somewhere here. 4.2 will be also in the third quadrant. So that this tangent, I assume it should be positive, because if it's in the third quadrant, the tangent is positive here. Go ahead and find all these values. I expect to see those answers in class. Now let's find the radian measure here. Theta is equal to r secant. Same thing as we did before, but this time, remember that if it's an arc or an inverse trig function, make sure you do 1 over the ratio. So you will say cosine inverse of 1 over 2.712. Here will be tangent inverse of 1 over 1.769. And here all you got to do is sine inverse. And keep your calculators in radians. Do find all these answers, please. Now here's the challenging part. This time we need to find the measure of theta in a specific interval. The first one says cosine of theta is equal to 0.5752. 0.752 is the positive value. Remember, which line represents your cosine? This is your cosine, your x value, and this is your sine. If the cosine is 0.752, apparently it's somewhere here. For the cosine to be here, knowing that this is 1, 0.752 is located here. The only way the cosine will be 0.752 is if it's in the first quadrant or the fourth quadrant. But here we restricted it to the fourth quadrant. Just use your calculator and find that cosine. Now, I will use my calculator and say I'm looking for the cosine inverse of 0.752. My calculator tells me it's 41.236. In other words, my calculator is giving me this value, 41.236. And what I'm looking for is this value down here, not the one in the first quadrant, but the one in the fourth quadrant. How will I figure this out? If it's located here, it means that they both have identical reference angle. All I got to do is 360 minus 41.236. And you can just do 360 on your calculator minus the previous answer. And it will give you 318.764, and that will be your degree angle that we're looking for. Any questions so far? If yes, save them for the class. That's what I'll be in class to answer this question. Now, let's look at the secant theta is equal to negative 5.127, and apparently it's located in what quadrant? Between 180 and 270. That's your quadrant 3. Now, again, I'm drawing my axis, and if it's in quadrant 3, it's located somewhere here. Now, secant is related to the cosine, so I will go ahead and draw another one of this nice triangle. If it's related to the cosine, most likely I'm looking for something here. Let's find it using our calculator, and this is what we will type: cosine inverse of 1 over negative 5.127. This is what I want you to type on the calculator. That's cosine inverse of 1 over negative 5.127, and the answer is 101.24. Well, we were pretty lucky here. It seems like the angle that we got is already in the restricted range. Is it? Well, it's not. 101 is somewhere here. We want the value that is here. Well, what is difference? I can say it's negative 101, but it's still not in my restricted range. What I will do to this is I will figure out what is the reference angle. This is 101, by the way. I'm gonna figure out what's the reference angle and add it to 180. So if I do 180 minus 101.247, that will give me my reference angle, and I will add that to 180 again. Or the easiest way to find it is just to do, if you do actually let's do it step by step. I'll do 180 minus 101. So 180 minus my previous answer. It tells me that the reference angle is 78.7525. So to this one, I will go ahead and add another 180, and I get 258. Why did I add another 180? In fact, once I found the reference angle was this portion, and it's identical to this portion as well. So by finding the reference angle and adding it to the whole 180, I get the measure of this side, and our calculator told us that the measure of that side is 258.753. We can do the same thing for C, and I will leave that up to you. I want to touch on example 6. Example 6 is slightly different. I have tangent of theta is equal to tangent theta if sine theta is 250. Sine is opposite over hypotenuse. Now I will draw my triangle, and I call this one theta. The opposite apparently is 2, the hypotenuse is 5. And I will just find the missing side by saying 25 minus 4, which is square root of 21. Now, tangent of theta is therefore equal to the opposite over the adjacent, meaning 2 over square root of 21. Feel free to be fancy and say 2 square root of 21 over 21. I believe you've worked with this type of problems over and over again. So I'm gonna leave this again up to you.